Good morning, dear students. Today, I would like to discuss about Java IO stream classes. This topic is in third unit. We have already discussed during our regular class session. To give an overview about these stream classes, today's lecture objectives are to understand the concept of Java IO stream and to outline the different types of stream classes, which are of two types, byte stream classes and character stream classes, and demonstrating some simple programs using these two types of classes. Now coming to this, the introduction about streams. Java reads the data that is called it as input and writes the data which is called it as output using streams. That means input and output, that is reading and writing operations, are done in Java using streams. A stream is nothing but it is a sequence of data, that is you can read the data byte by byte, or you can read the data continuously character by character. We read the data from input streams. That means here this is a source for a input. It may be a keyboard or it may be a mouse. So this is a source of input, we can say it as. Your Java program can read the data from this input source by using input stream class. Similarly, your Java program can output the data to a destination. The destination may be either a file or the destination may be either an output screen. So your Java program will output or write the data to any destination device using output stream object. So that means here input stream and output streams are the two different types of classes we will use to perform these reading and writing operations or input and output operations. So all input and output related classes are, that is IO related classes, are predefined in a package called it as java.io package. Java IO classes are categorized into two types, byte stream classes and character stream classes. How these two types of classes are differentiated? So byte stream classes are used to perform reading and writing or input and output operations using raw bytes of data. That is, whatever you are inputting through keyboard, each and every character will be read in terms of bytes. But when you are coming to the character stream classes, the character stream classes will read the data or write the data in terms of characters. In generally in Java, character will take 2 bytes, that is 16-bit. Unicode characters are used to store the character type of data. Now the byte stream classes are nothing but input stream and output stream classes or comes under byte stream classes. And character stream classes, under this we have a reader and writer classes. So reader class is for reading, writer classes are used for writing. So they are comes under character stream classes. If you see the class hierarchy, the byte input stream class hierarchy, if you see that, so this is the base class. Input stream is the base class in the hierarchy. From this input stream base class, so these are the subclasses which are derived from this input stream. So from this input stream, we have file input stream, piped input stream, filter input stream, byte array input stream, sequence input stream, string buffer input stream, object input stream. So from this filter input stream subclass, further we have derived 4 more subclasses which are line number input stream, data input stream, buffered input stream, and pushback input stream. So these 4 classes are the subclasses of filter input stream. So this is the class hierarchy of byte input stream classes. And in the byte input stream classes, these are the methods which are available in byte input stream classes for performing the read operation. Input stream classes are used for performing the read operation. So we have the method, read method is there. So 3 different versions of this read method which is used for reading. Input stream classes are used for reading operation. So we have simply a read method which returns integer type and does not take any parameters. So this read method reads a byte and it returns an integer value. That integer value is in the range of 0 to 255 because we have 256 ASCII characters we have. So once we read a byte, equivalent ASCII character will be written. That is, its equivalent ASCII code, which is of int type, will be written. Next, coming to this second version of read method, which will return again int type. So it is taking byte array as an input, one parameter, and another parameter is offset, and third parameter is count. So the difference between these 2 methods, read methods. So first read method is used for reading a single byte at a time. The second type of read method is used to read group of bytes. So it will read and stores the bytes into this buffer, BUF buff, which is a byte array, starting at offset, and it will read the maximum number of count bytes it will read into this byte array, starting at offset. So from which byte you want to read, that is mentioned here as an offset value, and how many maximum number of bytes you want to read, that will be specified as a count. And these many bytes starting from offset will be read into byte array. Now coming to the third form of read method is simply byte array. We are specifying that. So it is same as the previous one, but only thing here is that we are skipping offset and count. So offset by default it will take it as 0. That means starting for beginning from the first byte it will read, and maximum it will read the length of buffer. Okay, so these are the three different versions of the read method. And remaining three methods which are provided in the input stream are this skip method. So it will take the argument as count argument. So it will skips the count number of bytes from reading, and available, which returns an int. So it returns the number of bytes that can be read, how many number of bytes that we have to read, that will be written by available method. And next method is close method, which is used for closing of the stream. Now if you are coming to an example program, so this example program is used for counting how many number of bytes are there in a file. You take any text file. Now in the text file you want to count how many number of bytes are there. That is nothing but computation of size of your file. Generally, when you create a file, so the file will be stored in the hard disk. So when you open the properties of the file, you will see what is the size of that particular file, either in KB or MB, whatever it may be. So this program is used to count how many number of bytes we have in that particular file. So import the package java.io.star. So we are importing the IO package, and then you are defining a class count bytes. Now within this class you are declaring the main method public static void main. Then this main method we are defining in such a way that the method can throws file not found exception comma IO exception. Generally, when we are writing the programs on IO classes, so these two types of exceptions you have to handle it: file not found exception and IO exception. So the file not found exception is thrown when the specified file name, here I am specifying infile.txt. That means you want to count how many bytes are there in this particular file, infile.txt. Suppose with this name there is no file existing in your computer, then file not found exception will be thrown. And IO exception, generally this input output exception, when we are performing read operation or when we are performing write operation, read and write operations, whenever you are doing that, so you may get IO exception. For example, there is no data in the file, that is empty file, then you want to try to read the data. Similarly, when one thread is reading the data from a file and other thread is writing the data into the same file, then also there may be a possibility of exception we may get related to IO exceptions. Fine. So these two exceptions you have to handle in any program when we are writing these IO related programs, Java IO related programs. So at the method level, you are throwing this. If you skip this, you have to keep these statements in try and catch block. Right? So then coming to this code, I am declaring an object, a reference variable of file input stream. Okay, so file input stream is a built-in class available in IO package. So in is a reference variable of type file input stream. Then in is equal to new file input stream of the argument which file you want to open in read mode. So file input stream by default it will open the file in read mode. So once this infile.txt is opened in read mode, int total is equal to 0. So I want to count how many number of bytes are there. So I'm using this read method which is available in the input stream class. Just now we have seen the different forms of read methods. So I'm using the basic read method I'm using here. So in dot read, so it will return an integer value. So that is equal to the byte. So if it is not equal to -1, so that means it is not equal to the EOF character. So we are reading byte by byte. When we are this read method returns -1 means that we have read all the bytes from a file. So in dot read is not equal to -1, then total is equal to total plus. Fine. So this while loop is repeated until we read all the bytes from this file input stream, and every time total will be incremented within the loop. Then we are after exiting from the loop, we are printing the total number of bytes what we have read, total value we are printing that. Fine. So now what happens if the file does not exist? That is the question here. Just now I explained that if this file is not existing in your computer, then JVM, Java Virtual Machine, can throw an exception and terminate the program since there is no exception handler. Fine. Then coming to the byte output stream classes, so they are used for writing operation. So the base class for this is output stream is the base class. So from this base class, the subclasses which are predefined are file output stream, piped output stream, filter output stream, byte array output stream, object output stream. These are the 5 output stream classes. So filter output stream class, from this we have again have 3 different subclasses: data output stream, buffered output stream, and print stream. Generally these 3 classes are more frequently used here when we are performing the write operation. Now the write methods which are defined in the output stream class are, again we have a write method. So we have 3 forms of write method will there which is used for performing write operation. So write, it will take integer value b byte. So which byte you want to write? Then we have this is first method is used for writing a single byte, and the second form of write method, it will again take 3 parameters: byte array and offset and count. So it will write the count number of bytes starting from the offset from this buffer array, byte buffer array. Then simply we are specifying the third form of write, which is taking only the byte array. So it is same as offset is equal to 0, count is equal to length of this buffer. Then 2 more methods are defined. Flush, flush method is used to flush the stream, output stream, and close method is used for close the output stream. So these 5 methods, that is 3 forms of write method, 3 different forms of write method, and one is flush and other one is close. So these 5 forms of methods are defined in the output stream class. Now we will see one example program how we can use this byte output stream, so that here how we can read the data in terms of bytes and how we can write the data in terms of bytes onto the standard output device. So standard input and standard output, they are the 2 different predefined streams we have in Java. So in this particular program, just what I am doing here is that I am reading the data from the standard input, that is from the keyboard, and I am writing the data, same data onto the standard output. So here import java.io, then you want to define a class which is read write, and the main method which will throws IO exception. Now observe here, I am not handling file not found exception because I am not using any external file here. So just I am using standard input and the standard output file streams I am using here, std in and std out. So that's the reason here I am not handling this file not found exception. Okay, so then I'm declaring a integer variable b, because read will return an integer. So b equal to, I want to read the data byte by byte from the keyboard, system dot in dot read. So it will read a byte and it will be stored in b. If it is not equal to -1, then I will enter into the loop body and I want to display this b onto the screen, system dot out dot write of b. So this write method is used to display or to write something onto the output stream, that is the standard output stream, which is called it as your monitor. So we are going on reading the data from the keyboard and displaying the data onto the screen until the user inputs control D or control Z, which is indicating that end of file character. So these are the two programs which represents an example for byte input stream as well as byte output stream. So this is a byte input stream example, which is used for counting number of bytes in a file. That is one program just I demonstrated. And this is byte output stream. So this byte output stream we are using here to just demonstrate reading and writing, displaying something onto the screen. So when we are reading and writing characters, as pointed out earlier, we are using the subclasses of reader and writer, which implement streams that can handle characters basically. So the two subclasses used for handling characters in files are file reader and file writer. So generally, when you want to write the characters into a file or when you want to read the characters from a file, it is better to use this file reader and file writer classes. While opening a file, we can pass either file name or file object during the creation of objects of the above classes. So now coming to this character stream classes. So the character stream classes are basically reader and writer classes. So if you see the reader class hierarchy, which is used for performing the reading operation. So the reader class hierarchy will be like this: buffered reader, char array reader, input stream reader, filter reader, piper reader, and string reader. So these are the subclasses of reader class: buffered reader, char array reader, input stream reader, filter reader, piper reader, and string reader. So from this buffered reader, line number reader is a class which is defined as a subclass from buffer reader, and input stream reader, from this input stream reader, file reader is a subclass, and then from filter reader we have a pushback reader will be there. So these are the different uh, classes which are defined under reader class hierarchy. And under this reader class we have the following methods. Again, we have a read, three different forms of read method will be there. The only difference here comparing with the input stream with the reader class is that the read method here, it will take only the byte array, the first parameter here. Earlier we have a byte array, here we have a character array. That is the only difference. Everything will be same because we are reading in terms of characters. Basically characters will be again stored in the form of ASCII codes, right? So the difference is here, only thing is in place of byte array we are making use of character array. So same read method we can use. Then skip is another method which will be used to skip the number of characters, how many number of characters you want to skip from reading. Then we have a ready method will be there, which will return a boolean value, so it returns true if the stream is ready to for reading. Then close method, which is used for stream closing. Then one example program, if you see here, the reader method, which is used for reading of the data from files. So here I am using import java.io package, public class reader example, public static void main. So here in this example, I am showing here handling of the exceptions with try catch block. So instead of this try catch block, You can handle the exception at the method level, that is at the main method level, by making use of throws keyword. So throws space file not found exception, comma, IO exception, etc. Like that you can handle that exceptions. Otherwise you can make use of try catch block. Now here in this example I am demonstrating with try catch block, right? So I am creating an object reader. So reader some object name is equal to new file reader of some input file I'm giving here, file.txt. So that means I would like to read the data from this particular file. Then int data, which is equal to reader dot read method. So it will read the data, that is uh, from this file.txt file it will read the data. So while data is not equal to -1 because it is not equal to UF, then you want to print the data onto the screen. So you have to print the data onto the screen in the form of a character. So that's the reason we have to typecast this data, which is of int type, into char type. Then you will display the data in the form of a character onto the screen. Then next you have to read the next character from the data. So that is a file.txt file. You have to read the next character. So reader.read method. So this operation will be repeated until you read all the characters from this particular file.txt file. That is nothing but until you reach end of file -1 character. Fine. So once you come out of this while loop, now reader.close will close the reader object. Then here I am defining a catch. Now within this catch, now I am handling the exception. So exception is a superclass for all types of exceptions. So you can use exception simply, superclass you can use, or if you are familiar with specific about subclasses, you can write multiple catch block for each subclass type of exception. Okay, exception some ex. So then system.out.println ex.get message. So you want to display that exception message, what type of exception it has generated, that message you can print it by using this get message method in the exception object. Right. So this is the example program demonstrate you by making use of file reader to read the contents from a file. Then coming to the writer class hierarchy. So this writer class hierarchy, which comes under character output stream class. So this is a writer is a base class. From this base class, we have buffer writer, char array writer, output stream reader, filter writer, piper writer, string writer, filter writer. So then I hope filter writer is repeated here twice. Then output stream, from this output stream reader, we have a file writer will be there. Right. So these are the class hierarchy, writer class hierarchy, and we have the methods defined in the output stream. That is the character output stream. So we have the same form of write methods will be there. Three forms of write methods here, and the first three forms of write methods are similar to these byte output streams here. Only thing here, in place of byte array, you have the character buffer array. Fine. Then the fourth form of write method we have is which is used for writing strings. So you can give a directly string argument you can give, and you can omit this offset and int also. Just you can give write of string object you can give, which will write that entire string. But if you want to write only the portion of the string starting from offset and how many number of characters you want to write from the string, that in that case you can make use of this form of write method with three arguments. Then coming to this, two more methods here, flush, which is used to clear up the stream, and then close, which will close this stream. So now I will demonstrate this input and output stream, character input output stream classes, by making use of copying characters from files from one file to another file. So write a program that copies content of a source file to a destination file. The names of source and destination files are passed as command line arguments. Make sure that sufficient number of arguments are passed, and print appropriate error message if you have not supplied the sufficient number of arguments. So this is a file copy program which we are demonstrating here under this input and output stream, character input and output stream, which is file reader and file writer. So the number of command line arguments must be minimum two, that is the source file name and destination file name. You have to specify that. If the args.length is not equal to 2, that means you have not supplied specified number of command line arguments. So I am displaying error message, insufficient arguments. Then usage is ela use cheyali, how we have to use this program, how we have to run this file copy program. Java space file copy space source file name space destination file name. So here minimum 2 arguments should be there after this file copy. So then system.exit -1. This is a error we are displaying if you are not supplied sufficient number of command line arguments. So if you have supplied sufficient number of command line arguments, then this is a source file name is stored in args of 0 location. Destination file name will be stored at args of 1 location. Now from the source file, you have to read the data and you have to copy the data, or you have to write the data into the destination file, that is the writer file. So you have to open the source file using file reader. So file reader, some src file which is an object of file reader type. Then I am creating a file reader object with the args of 0. This is args of 0 contains the source file name. Then file writer, because you have to write the data into the destination file, so I'm taking a file writer object and I'm creating an object for this file writer. So file writer some dest file is equal to new file writer of args of 1. Then I'm reading the data from the source file using the read method. So ch is equal to src file dot read. So if it is not equal to -1, that means we are not reached to end of file. Then the ch we have to write into the destination file dot write of ch. So this you have to repeat until you reach to the end of file in the src file, source file. So once you reach to EOF in the source file, that means you have copied all the characters from source file to destination file. So then I will close this source file and I will close the destination file. Then if any IO exceptions are there, so catch IO exception some e system.out.println e, then we are exiting from this program. So this is what this system.exit we are using here just to terminate the program with this error code. Fine. So this is the program which demonstrate copying of one file to another file using file reader and file writer. So when you run this program, how we can run and how the output will be displayed. If the source file exists, that means you are given Java file copy file in.txt file out.txt. That means you want to copy the contents from file in.txt to file out.txt. Source file does not exist. That means file in.txt does not exist. Suppose. So Java file copy abc file out.txt. So Java IO file not found exception abc no such file or directory. If the source file is not found, so no file not found exception will be generated. Suppose if you have executed the same program like this Java space file copy space file in.txt. So you are not given the destination file. So that means sufficient number of arguments, 2 arguments should be there, arg s of 0 location and arg s of first location, that is source file name and destination file name we have to pass it. So we are not passed the destination file, so we will get the error message insufficient arguments, usage is Java file copy source file of destination file. So this error we have just handled here. So when args here we have handled that. If args dot length not equal to 2, that means you have not provided the sufficient number of arguments. Fine. So this is what the execution of this particular program is. So now coming to this buffered streams, generally we are using here buffered stream classes we are using that. So when we are using this input output streams here, we are directly reading the data from the specified input stream and we are writing the data onto the specified output stream. So when we have the external devices for performing this input and output operations, so every time, every character or every byte when you want to read or when you want to write from the external devices or to the external devices, it is a time consuming process. So that's the reason here to make more efficient, here we are making use of a buffering of IO operations. So that when you are reading or writing the data to a stream, we are making use of a buffering and once the buffer is full, we can flush that buffer, or we can perform the respective IO operation. So that's the reason here we are making use of buffered stream classes. So buffered stream classes we have here: buffered input stream, buffered output stream, buffered reader, buffered writer. So buffer data to avoid every read and write operation going to the stream, so that the memory operations will be reduced here. So these are used in file operations, since accessing the disk for every character read is not efficient. Okay, so for efficient IO operations in files, we are making use of these buffered streams. We are using this. So buffered streams, if you take here, buffered character streams, they understand line of text. Okay, we have as one line of text, so every line is terminated with a new line character. So if you use the buffered stream, it will understand where the line is terminated. But when you are not using buffered streams, simply if you are using normal character streams, or the byte streams, if you are using that, it will also read character by character in a continuous fashion. But if you use buffered readers, buffer writers, these will have a buffered writer will have a new line method which writes a new line character to the stream. Buffer reader has a read line method to read a line of text as a string. Entire line you can read instead of reading character by character using read method. You can read an entire line until a new line character. You can read entire line as a string. So we have a read line method, so which makes efficient. For complete listing of methods, please see the documentation so that you can understand these buffered streams more clearly. So now in this example, we are demonstrating the buffered reader to read a file one line at a time and print the lines to standard output device. So here we are using buffered reader. Line by line you are reading. Instead of reading character by character, I am reading line by line from a file. So buffered reader. So I'm defining a class here, some class name, public static void main method. So here at the method level, main method can throws file not found exception and IO exception. I'm defining at the method level, I'm handling these exceptions. So you can omit try catch block. So I'm declaring a variable buffered reader, some in. So in is equal to new buffer reader of. So you want to read from a file. So you have to make use of a file reader. So here, one thing you have to observe here, the file reader we are combining with buffered reader. Why we are combining? Because you want to read line by line, you want to read that. So to read line by line, you have a read line method in buffer reader class, not in the file reader. So file reader will have a read method to read character by character. So I don't want to read character by character, I want to read line by line, I want to read that. So that is the reason here you cannot directly instantiate an object for buffer reader. So you have to pipeline this file reader to a buffer reader so that you can read the data from the file line by line. So we have to join two readers, you have to join here. Okay. So then I want to read the data line by line from command.txt. Then I'm reading like this: line is equal to in dot read line. In is an object here, buffer reader object. In dot read line. So which returns a string. So I am declaring line as a string. So line is equal to in dot read line. So if you read a null string, that means you have reached to end of file. So until you reach to the end of file, you have to read the line by line from the file and display the same line onto the standard output, that is system.out.println line. So this is a simple program which will read the text file line by line and display onto the screen. Right? Reading and writing bytes. So the file reader and file writer classes are used to read and write 16-bit characters. So as most file systems use only 8-bit bytes, Java supports number of classes that can handle bytes. The two most commonly used classes for handling bytes are file input stream and file output stream. So these two most commonly used classes for handling bytes. So this is another example showing you how we can write byte arrays into a file using file output stream. So I'm declaring an array here. Byte city is an array. So here HY Hyderabad, then backslash n, then Warangal backslash n. So like this you are declaring this is one line and this is another line. So you are declaring all these characters as a byte array cities. Then I am using file output stream. Then I am creating an object, new file output stream of city.txt. Then into this file output stream, out file dot writes of cities byte array I am giving here. This is the byte stream, writing of byte stream. Then I am closing out file dot close. Then you can see that you can uh, you can see that here whether this array or this string is stored or not. Just open the ct.txt file in the notepad and observe that whether these strings are written into the file or not, right? This is how we can do it using byte streams, basically file output stream, which is a byte stream. So all Java classes are designed to operate with exceptions because of file not found exception or IO exception. So user exceptions and your own handler with the files to manage runtime errors. So subclasses file reader and file writer support character based file IO. File input stream and file output stream classes support byte oriented file IO. So buffer reader operations support efficient IO operations. So these are the few things what we have discussed in today's lecture. So hope you understood the concept of IO. Okay. So thank you one and all.